Okay, we have here another integral on the board. We've got the integral from 3 to 5, cosine of the fifth 11 minus x over cosine of the fifth 11 minus x plus cosine of the fifth 3 plus x dx. Okay, I know I've done a lot of problems like this in the past, but I just thought it was interesting thinking about the fact that we usually have this going from 0 to pi over 2, or some kind of, we usually have pi in there somewhere. Because it seems like it'd be messy to calculate these bounds on cosine functions, especially with it shifted like this. But it turns out we don't really have to worry about any of that right now, because it turns out this is a case where we can use King's principle. We have here the same exponent on everything, same function. So I'm just going to go ahead and do it that way and make the substitution for King's principle. So what we do first is I'm just going to add the bounds together, 5 plus 3, 8 minus x for my substitution. And so isolating x, we have x is going to be equal to 8 minus u, and we'll take our derivative, dx is going to be minus du. So now we'll just go ahead and we'll update our bounds. So plugging 5 in someplace, plug 5 in here, and we have 3. Plug 3 in here, and we have 5. Then on this numerator, we're still going to have cosine to the fifth. Now we need to take 8 minus u and plug it in here carefully. This is going to give me 3 plus u. Then this term here is exactly the same, so I'm just going to copy down what we just did. Cosine of the fifth, 3 plus u. And then for this one, plugging 8 minus u in here, that's going to give me cosine to the fifth of 11 minus u. Now on the du, let's not forget that we've got this minus sign here. But I'll just take that, and we'll just use that to flip the bounds. We'll bring it out here, get rid of it, and swap our bounds. But next what I want to do is let's just do a variable change. Let's get everything back into x so I can add these two things together. Definite integral, so the variable name doesn't matter at all. It doesn't change the area under the curve. So I can just change all this stuff back to x. Then I'll label our original integral I. We'll label this one I, and we'll add these two together. So that's going to give me 2 copies, or 2i. We have the same bounds, so we're going 3 to 5. Now notice we've got the same denominator, just in a different order. Okay, so we'll just basically copy all that down. And then we'll just add these two numerators. So we're going to have cosine to the fifth, 3 plus x from this one. And then here we're going to have plus cosine to the fifth, 11 minus x. But then here's the payoff. We can just cancel everything because we've got the same numerator and denominator. So this whole thing cancels down to 1. So then we'll just go ahead and we'll integrate it. So this is going to give me x evaluated from 3 to 5. So plugging in, we're just going to end up with 5 minus 3, which equals 2. But we need to keep in mind that we're dealing with 2 copies here. So we'll divide off the 2 here just to isolate 1 copy, our original integral, divide by 2 here. And so for our final solution, it's just 1. Okay, so there you have it. I think I've done the King's principle more than anyone on YouTube, 200 times. I don't know, I'm just making up a number. Thanks everyone for watching. Have a good day.